Okay, so I think we've got enough people here today. I will just kind of get us up to speed with where we were. Just let me share my screen.
I saw that you shared something about the Twitter design on LinkedIn, right?
Mm-hmm.
Yeah, I think, the Ramya also pointed to me about those. So I think we should probably interleave the chapters with some design question reviews also. I think that will, because this is not a small thing, right? Like it will take for a long time. I think we will spend the rest of the year reading this. But
Yeah,
yeah.
that's true.
Uh,
In fact, go ahead. Go
yeah,
ahead.
I also got the first version of the book by Alex Liu. He has a book called System Design Interview. There are two parts to the book. Second part just got released 10 days ago, and the first part a couple of years ago. And yeah, it is methodical. I think the book goes through 10 to 12 design problems, starting from definition to taking the problem through completion. So maybe we can use that book also as a guide to go through one problem from that book, alternating with it. Maybe once in a while. Every 2 weeks, maybe we'll go through one problem with the book so we can relate
Yeah,
the
I think that's
concepts.
yeah. This is kind of not, this is good to know, but like not directly relevant to our everyday jobs, right? Like the GraphQL and all, but it's good to know what's out there. But then I think that's more ROI perspective. I think that's reviewing design questions is going to give us more returns. Anyway, yeah.
So I have a question that I was asked in an interview, and I thought it might make for a good system design program or problem. So if you want to take a detour today, we could try it out, and then we could finish out this chapter because there's not a lot left on it anyway.
Yeah.
So just, I guess let's take a few minutes here then, just kind of talk it out. Do you all know what a phone book is?
What?
A phone book is.
Mm-hmm. Okay. Yeah, phone book.
Yeah, phone book, yeah.
I haven't used that in years, right? Like a big fat phone book with all the people's names.
Mm-hmm.
So if you were to design that on the web today, like an online version of the phone book, how would you implement the system design? So maybe anybody could take a stab at that.
Uh, the phone books used to be personal devices, right? When you wanted to bring it online, is it going to be still personal for one person, or it's
No,
going
I
to
think
be?
he means yellow books, right? Those yellow books, the big
Oh,
ones that the city publishes.
Yeah, the visual help. Yeah, exactly.
the
So
white pages
telephone
kind of a
directory.
stuff. Telephone
Yeah.
white. Oh, okay, okay, okay.
Nobody
Okay.
has this anymore.
Okay, this equivalent of white pages, right? Somewhat.
Mhm, mhm.
Okay.
Yeah. So why this is anything, but this is so painful to use, right? Like you have to kind of manually um, go to the correct index and kind of pick what is the experience the user wants. Like, is it just they just want us to be able to look up a document database kind of a thing with the name, like autocomplete kind of stuff, or what do they want us to do?
Yeah, so they want something that looks kind of like a phone book online where you can search for somebody's name. Maybe like the way you would do it is you would go through, look for, let me see if there's like a clear,
Yeah,
yeah,
the last name and first name, right?
like a last name or a first name, and then just be able to get the information back. So like I'm looking for Smith, Mary Smith,
Mm-hmm.
and I want to find the one at Dollhouse. So how would I get this person back? What would the
Mm.
process be? In the old days, you had to like turn the pages and keep looking until you found the person that you were looking for. So
We can do better now, right? We can do
yeah, oh, way better, way better, way better. this
so.
this problem is already solved, by the way. Like
Right.
there's
It's
a
beyond
tool.
solving.
There's a tool
Yeah.
that I hope everybody knows. It's called Google. So
yeah, it's like a document search, right? Yeah.
mhm.
Yeah, it's similar to, yeah.
Yeah. There are services that do that. We don't have to solve it. Elasticsearch, OpenSearch, whatever.
Exactly.
Yeah, yeah,
So
yeah. How do you want, should we come up with a framework for solving the problem? So we talk about those points rather than starting from one end and figuring out, like going in a random
I'm
fashion. Yeah.
I'm
Do you
open
have
to
like a,
anything.
okay.
Like
So,
just take the time
you
to like think about everything you've learned,
mhm,
and just freeform like a response.
mhm.
we
I
can
could
take
even
turns if you want to take turns. Vijay, if you want to come up with your ideas, then we can brainstorm together. Like we can take turns and come up with ideas.
okay. All right. I'll go last.
Sure. Yeah. So I think
Um,
the first, I can go first. I'll just rattle it out, whatever comes to my mind, and we can fix it on the way.
mhm,
Uh, I think the first step is to understand the system requirements, right, to design this phone book.
mhm,
Uh, so, what is the user experience needed? Somebody is going to add some element to this phone book, or some service is going to, somebody relocated or somebody gets a new phone number or an address, they are going to be added. And there is also going to be a read, which is more than the write. Write can happen less frequently and read can happen more frequently.
mhm.
And write will be probably by a service, not by an individual user, but a read will be by a user of the service, because read is just lookup, and that's one high level requirement. Read is more often than write. And the second is uh, the service, since it's online, it has to be probably, how do we want it to do? Always available, that would be better since it is more read. Um,
So
then,
I'm
yeah,
just gonna help you out by like
sure.
writing some notes just
Yeah,
so
yeah,
we have it here.
yeah,
So
yeah,
anytime you want me to make a bullet point, let me know.
yeah. First is read is,
More
uh,
frequent than.
yeah, more frequent than write. And to give users a better experience, they don't want to search and get the results in after a few seconds, right? We have to get them in very quickly. So low latency read is preferred.
Okay. Okay.
And for read, the service, we prefer somewhat an always available service for that.
Okay.
So okay. Uh, so these are the, and next is, what are the issues? So if somebody need to be logged in order to access this thing, or they can be, um, it can just like be Google, like you look up and everything is public information. That is something we need to think and design. Do we need a, um, yeah. Um,
Mhm.
okay, so these are the high level things I can think of. We can, and the second part I wanted to framework it, add to the framework is like simple APIs.
Okay.
How do we have this, right? I mean, user facing is something, we are not going to design the UI in system design, but simple APIs, what we need, right?
Mhm.
Basically, we wanted to have a, add to the database, which will have a user, uh, maybe some add user is one API, and that API can have what it can take: user first name, last name, address, and phone number, right?
Okay.
We have to decide on what is the primary key for this. Definitely, there will be more people with the same first name and last name. Maybe same residential phone number address will be shared by many people. So maybe we can decide on first name, last name, and phone number as the key, which
Okay.
probably could be unique.
Okay.
Okay, since read is more, and the next one is like the read from database. So how do you look up using the first name and last name, right? So we need indices built based off this first name and last name. So read or get is like maybe first name or maybe last name, depends on how the user wants it, right? Today, I think they typically search on name. I don't know if they, most likely they don't search on address. So depending on how the user experience want, we can have different APIs for different reads, or search by name, search by address, or search by phone number, and gather the information accordingly. So the read will have multiple flavors, right? Since these are the two high-level APIs we may need to design, next we can go into the storage format, the database. How do we want it to store all these data, right? Let's think about a case. Let's not look into scalability now, and then we can add scalability for everything later. Initially, like, what does this data look like? Like for every user, we have these things, and what are the different types of databases, SQL and NoSQL.
Yeah.
Here, we wanted to read the data faster. The read latency has to be lower. So it is good to have data locality. We want all the information with respect to somebody stored in one location. So probably NoSQL document databases, something like that is a good go. That's the initial thought. So once we have this storage format, then let's say, how do we search? If everything is stored in just one machine and there are 20 million records, we may run out of space in future, or the search itself could be very sequential, and we may have to speed up the search. So the next is, we can scale it out, store different records in different machines, or the database itself is partitioned across different machines. One is for speed of search and the other is for just scalability purposes.
Do you have to design it to that database storage? Do we have to design it to that detail? Normally we pick a DB and that would be the the system. We don't have to worry about like how the data is partitioned inside the DB, right?
I think the crux of this problem will be mostly like, how do you partition, and that's the main part of the problem. What you use as the hash index for partitioning here, right? If you use just a first name, right, there will be less number of names starting with O and more number of names starting with S. So there will be some discussion points. I had similar questions in interview before, so people would like to go over various forms like this and talk about, yeah, we know database does everything for us, but an idea of how would you partition and what hash algorithm or what technique you would use to partition the data is somewhat there. Is that what they are looking for in questions like document databases or indexing?
Right.
Yeah.
Okay.
So now DB is partition. So now we have to, for read, let's say now we are talking about read, right? If there are DBs partitioned, then we have to run that search command in all these DBs and then aggregate the results. This is called, there's a common term, aggregator pattern for these type of questions, where you can parallelize the search on multiple machines. Each of them will give something, and then you can aggregate it. It's a two-level diagram. I forget the diagram. As you can see, there will be multiple nodes and each running its search, and there is an aggregator running in one common node, giving the results back to the user. Let's say if we have such a algorithm. After that, now the main question is, how do we partition this? There are many ways to partition, by first name, last name, by locality, by recency.
So yeah. I'll help out with kind of like with what my interviewer was asking me. Like, so he kind of said that he wanted to start off like with, just understanding the model, like what kind of model are you going to have? And I think he kind of started it, which is great. So I'm going to just continue off that. I think he said that you chose that you wanted to do a document, and no SQL document would be ideal. So why did you choose no SQL? And what are those advantages over something like SQL?
Advantages is data locality. You can store everything in one table, and then it's it is more suited for this application where it's all textual data.
I think, okay, yeah, I'll hold off.
Yeah.
But, yeah, go ahead.
Yeah, these two are the points which came to my mind. Yeah.
Okay, so if you use NoSQL, and assuming that it's JSON data, then how would you retrieve a record? Let's say, I'm looking for, your name, Ramya Priyadarshini, right? So how would I find your name with this data? Like so we've got the data model, and then, like we've got, what kind of data structure should we use to hold all this data?
Oh, okay. So key value something, and we need an indexes in order to go and retrieve the data, right? And we have to build these indexes based on what the user search criteria will be. So let's say the user search criteria is first name, last name, then first name, last name could be the key, and the value will be pointing to all the records for the key value pair.
Okay, so your data might look like something like this.
Yeah.
And then it would point to all the other information. So would you have those as key value pairs, or would you just have that as an array?
It's like a it's an index, right? So this will be this is for a single user, are we talking about indices?
I was going off single user.
Oh, okay, single user record. Okay, record will be like first name, last name, phone number, and address. Yeah.
Okay. All right. And I'm just going with basic string types for now.
Yeah, yeah.
This is what I imagine the data would look like.
Yeah.
Okay. So then from here, so how would I find your name? Like what kind of,
so we have to have some in-memory indices. So the indices can be, let's say we allow the user to search on either first name or a last name, right? So the index data structure itself could be maybe hash or SST tables. I forget what SST tables really do. So in that, the key
what was the question? You want to
build an index, search for that. So how do we search, right?
Yeah,
because that's the question anyway, right? I think like they're saying like system design a phone book, and I guess at a high level, how would we find somebody's name, right? Like just like in this example here, like the old way.
Yeah, in the phone book, right? You don't go directly to the name, right? There is no way to directly, if you were like manually going, you would eliminate. You would first say, if you're looking for Ramya, you would go for first
binary search,
starting with R and then A, and then if you eliminate the others and then go to there, right? Like you're trying to zero in on the record. That is more analogous to the autocomplete thing that we do, right? First, you get very broad range of records, and then you kind of drill down. So so you don't wait until the complete name is given, and then you go fetch. It's not like one call. Every keystroke is a call.
Mhm. So you're thinking something like the front end basically is like keystroke down, and then narrow the search, fetch calls or something.
So you don't have a key that you can look up. It should be more like anything that starts with R, anything that starts with RA kind of.
Like autocomplete for Google searches also, right? Like you
Right,
are doing
yeah.
that. Okay.
Mhm.
Yeah, so that is the main reason why SQL wouldn't work, because you want the entire name to be given to actually look up one single record. That's not the use case here, right?
Yeah, good. That's good.
That's a great point.
Yeah, so you would, but I do think that what the aggregator pattern is the approach here, and you would use a NoSQL DB for unstructured data. So
Hey, Amol.
Hello.
So for you said NoSQL, SQL will not work here. You can have like something like there is a like option, right, in the for SQL queries. So like, suppose my name is Ramya, so I say R. The starting letters are RAM. I type in the search bar, and it looks. The query will say select first name, where first name like RAM, and anything with RAM. Right. So
you're saying you would. Yeah, okay, so is that how you don't have to give any other, you can just give that as a filter and it will basically return. There is no other. So right here what you have is just that, right? RA is a string that you have. You can I forget how to write a SQL query for this. So you just say, like, I know that there is something like that wildcard matching stuff,
yeah.
but is that the only you can query records from SQL with just one filter like that?
Yeah, you can, yes.
Okay. So
I'd like to say one thing like this has happened with me in system designs. I was in an interview and very full-fledged. It was like a it was a we were doing what we do in Confluence, right? Like Google Docs. And I said, hey, I'll go for NoSQL for storing data, like because it was all it's a huge data set and something. And the interviewer responded to me that, hey, we use MySQL in production. Why are you going with NoSQL? So keep like that was the first like that. And that was one of the experiences I had, that keep things simple, start with relational. And because you know how to, wherever you know how to write your queries, and then you can give better APIs. And uh, start with that. Although if you can, because if you have to iterate sooner and sooner, then it is good option to start with NoSQL. But otherwise, I would always suggest to start with, for system design problems in interviews, start with MySQL.
no, so the what was this? So the same exact question was asked. Like, was
This
this?
was not the same exact question, but this is what I'm telling. Like when people ask in system design, what kind of database will you choose? I don't have any experience with NoSQL, right? I'm not using in production a lot, or I have not used it much in my experience. So how much will I be able to justify the usage of that if I don't have experience in that?
So we discussed this, right? This was the chapter in one big red flag for me would be evolving data structures, data models, right? So when you add a new column, or like when you like, yeah, if you have everything fixed at the day one, right? Like when you're designing the database, that's not how it typically is. You want to add new features, you want to add new data, new attributes to the records. So that's not easily done in SQL. You see what I'm saying? So that's one thing. And secondly, so we have evolved to a place where you can so almost, I mean, the advantages that you have with SQL is that you can easily look up using indices, and basically your keys are kind of make it faster for you to look up if you have a specific use pattern, right? Like access pattern, then you can design your indices and table hash keys accordingly in SQL. Similar thing, I was surprised to know that like similar thing is possible with NoSQL also. Like you can create indices and make the it's not true that although it is not structured, you are if you are doing a if you're doing a weird access, if a use case came up that you didn't anticipate before, you can always create a GSI, in this, just like you do in SQL, and it's you can basically evolve at that point of time to create a new index and fasten your queries. So, and also the data locality, that's another thing that's going for that's the disadvantage for NoSQL. So, I mean, that's enough reasons for me to go with I mean, I have to be convinced to use SQL, not the other way around.
Oh, Karthik, you have your hand raised. Go ahead. I don't think you need to raise your hand. I think you can just ask. Or maybe that was an accident on your part.
Yeah.
Okay.
No, it broke up. I think the golden rule I would go back to is like, do you need asset properties? Like your transaction has to be committed right away, or eventual consistency is acceptable, right? That would be the golden rule that you would go, choosing SQL versus NoSQL. There's a good paper, maybe I'll send the link, like, and I'm pretty sure you guys know. JSON is supported in both MySQL and Postgres, and these days even in Oracle. So essentially what I'm trying to say, you can create a JSON structure even in RDBMS. You can. You'll have the same flexibility of not having to change the schema and stuff. So, and I've used in one of the customers that way. They used MySQL, same MySQL. They needed flexibility on some of the models. And then they needed flexibility of RDBMS in some of the data models, right? So it's called NewSQL. The book doesn't cover it, but typical candidates, I think even DynamoDB, Google Spanner, and all fit into the NewSQL model, where it supports both asset and base properties. That is the rule of the first rule of thumb would be that. Second rule is like, RDBMS are read efficient. NoSQLs are generally write efficient. If your use case will allow eventual consistency, or for example, a lot of data that's being emitted from like any kind of IoT devices, machines, and stuff like that, NoSQLs fit the bill fine, because it will store the historic data. So a lot of factors drive it, but traditionally, like how Ramya mentioned, the world always goes to starts with RDBMS, and they iterate it, and as the use case evolves, they generally have hybrid. Most likely they end up with hybrid, where they have RDBMS and NoSQL as well. And then slowly they just like pivot as they go along into NoSQL structure, from my experience.
How does RDBMS achieve this consistency, right? Like, so if you write to a table, doesn't it take time to write to the index? Like, is it instantaneous? I thought they're like, go ahead, somebody has an answer. So I thought when you have indices, you are inevitably dealing with the eventual consistency.
No. What happens in RDBMS is it's written, the write logs are written, right? I think Ramya also mentioned sometime back, maybe a couple of weeks back. Generally, the write logs are written, and then what happens is the write logs write it into the storage, and the indexes happens after the fact that data is written, right? That's a database property. So it doesn't wait till the indexes are all tuned and data is tuned. First, it writes into the storage. That's where our acknowledgement is. If you think from asset properties, like atomicity, consistency, isolation, and durability, I'm sure like in J2E, generally we discuss this like two-phase commits where you have two transactions. You always in the driver, you'll set the auto commit as false. You want to make sure either both goes in or none goes in, right? So that property of the reason why we do that is like it writes it right away, at least in the logs, and then it goes and writes in the storage. But indexing the whole data happens after the fact by the database.
Right. So that is eventual consistency, right? So
not necessarily. Consistency is a property where you write the data. What you wrote, let's say I write Amulia into the database, it should be Amulia, right? That is right away.
But what if I read the index meanwhile, right? Somebody read I updated my first name and somebody went and read the index and they would still see the old value, right? That's the eventual consistency we're talking about. Your index is not in sync with the table.
No, correct. But in RDBMS, if you notice, there is always, even in a multi-cluster mode, it's single server write, and then there are read replicas. Excuse me, read replicas, right? Where it just transfers. But in a NoSQL world, it's distributed database. The reason why we say eventual consistency is, let's say we have a whatever NoSQL structure. One is, for sake of just simplicity, I'll just say, okay, there is one instance in wherever you live, San Jose or Sunnyvale, one instance like in Europe, and another instance. And for sake of discussion, I live in Europe and Ramya lives in Australia and stuff. So there are instances, but together they are clustered. When Ramya writes it from Australia, first, it won't come to all the servers. First, it will go to the nearest node that she can access, where she'll write in a NoSQL. Right. Once that's done, the NoSQL structure, depending on what protocol it is, if it's gossip protocol in Cassandra or like MongoDB kind of a structure, that will distribute the log. It will send the data to all the other clusters, right? So that's why it's eventual consistency. The reason is, let's say she wrote it there and you access it here, you will not get the data. Right.
Right.
Data. It takes time.
That is the property of distributed databases. There is no requirement that your RDBMS has to be local. It should not be a distributed, right? It's a parallel dimension. How your database stores the data for faster access. That's another dimension. Like it can be applied to both. The question about whether to choose SQL or NoSQL primarily depends upon the access patterns you have and the data models that you will have. Like if it's an evolving faster, like if it's a frequently evolving data models, then you would choose one. So this is my understanding. Maybe first point to the discussion is whether it is distributed or not is not a relevant point to choose one over the other, because you would have distributed versions of SQL as well. That's actually mentioned in the textbook as well. They say there's nothing in RDBMS that prevents it from being distributed.
Oh no, nothing. But NoSQL has to be distributed. By default, you need to have minimum 3 nodes. Because that's how, for example, now Cassandra and all, quorum and leader is elected. Leader is like the control node, and so NoSQL by default it's distributed database. That's all. That's its property. But RDBMS I can still run without distributed. I can run a single node, and then I can have multiple read nodes. Right? Read is different. It's like idempotent, like right. The data only refreshes from other place, and only for read capability is provided. Distributed is a property of NoSQL by default. For RDBMS, it may be needed sometimes based on but they do it different. They are never together as part of the cluster. They have a separate machine in each location. And then there are a lot of data syncs happen, active data sync, passive data sync. That's why the whole ETL comes into play, because RDBMS doesn't play well in a huge cluster from across with partition tolerant capability, right? Across regions. When I say regions, it's different geographies.
Yeah, because when at work we use DynamoDB, right? And the DynamoDB, they say it's eventual consistency. When they say eventual consistency, what they mean is there are indices that are not that may not be up to date with the table record. So that is the SLA they are, but they never say that you write to a record and then there is a possibility of a record showing incorrect data. That's not a that's not something that at least I'm aware of making a design choice about. So that's something
It can be, right? It depends on how fast your database is, what are the latency involved across network and stuff like that. You could see a different version of that same data, but eventually it will all sync up and everything will be same. That's why it's eventual consistency.
Okay, so let's come back to the main part of the question, right? I think like we just kind of focus on this part, right? How do we allow the user to search on first name or last name? Like what would, I guess like we've got some good discussion about which database to use, SQL versus NoSQL. I think we were going with NoSQL for now. Is there a way we could work with NoSQL, given its advantages, and say that we're good on this, being our data structure? Then like, how would we implement, like, I guess, just the next parts, right? Like, what would, the search look like itself? And then, how would you be able to get that information sort of fast, or I guess like improve like the search? So how would you implement getting the search, and then how would you make it faster for the user?
Yeah, so okay, go ahead. Ramya, you had something.
I'm thinking of like Google inverted indices is one idea for search, where
Google inverted index like this?
yeah.
Can you give us like some information about it? I actually have not heard about this, which is interesting.
It's been a while since I read this also, so I just remember the term.
Okay.
Yeah.
Anyone else want to help contribute
To inverted index?
or to the general discussion?
Actually, no, I have to read up.
Okay. So, all right, let's just review what we have so far. At least I think this is a good exercise in case, just, we can always kind of come back to it afterwards. The system design a phone book at a high level. I'm going to move this up here and say it's probably 0.1. Users don't want a slow experience. Low latency read is preferred. We are going to be reading more than writing to the phone book. The service is always available online. And then everything in phone book is public info. Private shouldn't be shared. So that's the high level. Then for the back end, we need a user API where we can add users by first name, last name, phone number, primary key, address. Should be easy to read and get based off of first name or last name. The storage format, we talked about NoSQL being ideal. One table, all textual data, locality. So that would be good, just to have it available, right? And I think that helps with not wanting a slow experience, because if the data is all local, it should be faster to search for the user, right? In terms of scale, if this thing starts growing, right? And maybe I'm reading ahead too far, but it says there might be more names starting with S than starting with O. So we may need to partition this data document, right? So that's something that NoSQL offers as an advantage. So that's a good point. Running a search on the databases would entail like making a search call and hitting multiple partitions and then aggregating the results.
Yeah, that's a good approach. Another thing that's missing here, I would do that is ranking the results, right? Not all matches are might not be super relevant. Like for example, if you are looking for RA, you would first want to rank the names, name matches first, and then address matches next. So you would want to give some weight to the, so the result should give, the results that you get from DB should tell what matched, so that you can apply the weights accordingly. Yeah, basically you kind of do the search with first name, last name, and then so you basically each API call is basically is searching for first name matches, last name matches, and address matches, and then you kind of multiply them with the weights, and then you rank the results.
So going back to this example here, right, the phone book was already sort of pre-made. So do you think this is a simpler experience for the user, or do you think this one is simpler? In that there is no ranking, right? It's just more or less, well, there might be a ranking structured by ads, but
yeah, here you know what you're looking for, right? So if you're looking for an address, then you are in trouble, right? How it's all ranked by the last name. I mean, it's all ordered according to the last name. Okay, so if it's similar to the phone book, then you don't search from the address, right?
Yeah.
Address is not a such thing. Okay.
Yeah, I'm just comparing user experiences. One is a phone book, right? Let's just imagine this is 1990, right? And you're trying to convince somebody to use something called the internet, right? And you're like, why would I do that when I have a phone book?
Mm-hmm.
And this is an actual thing that happened. I remember people used to like give me a phone book like way back in the day, like when I started like working, and they say, call this person or call that person. And then I'd say, can I just use the internet? And then they would get mad. Like, why do you need a computer? Just call. So this is like when I was like an intern.
Yeah.
I briefly looked up my notes on inverted index, so I can give a pointers.
Okay.
So what inverted index means, let's say you have a record here, each name, first name, last name, address, and phone number is a record, and you can split into multiple words, right? First name is a word, last name is a word. Street name is you can split that as one word. So what inverted index means, you build an index where key is a word and the value is where all the document IDs where that word has been used. For example, if you look up Ramya, there will be 100 Ramya records, right? First name Ramya. So the key will be Ramya, value will be all the records or IDs of the records or where Ramya exists. So this is inverted index. So you build and from this is useful for search, especially for speeding up the query. If you just want to look for Ramya, then you go to every partition. There is an inverted index there, get all the records which has Ramya, and then you send it to the aggregator. Aggregator then probably just combines all the results or applies second search criteria or whatever it is there, some filtering mechanism. Maybe you wanted to give Ramya only in the US region, then it will just pass on the, so aggregator does typically some filtering if needed.
Okay.
In a document, it makes more sense when you're doing a document search. Every document will have like probably 100 words in a page. They will remove all these common words like is, and, remove everything, and other words they can build an index for each word. What are all the documents this word exists in? And building this index is a very expensive operation also.
Okay. I'm just also just scanning this article as I'm seeing it, so I get an idea. Okay. All right. So we could potentially use an inverted index. Is there anything simpler we can do? I guess like maybe that would be like the thing. I can share it if no one wants it, if no one has it.
I think for this, if we restrict the criteria to be searching by first name or last name, we can just restrict this inverted indexing scheme just to first name and last name, right? You build for all the first name, what are the key will be the first name in the index, and the value will be all the references, all the record IDs of where this first name exists. Similarly for last name.
Okay. All right. So if you have 100 million records, how fast or slow could this be based on like the inverted index or, you know, like anything else that you add? Like how long should it take to get like a name? What kind of, I guess like what kind of code here would you have?
For a read, right? We are talking about it because write is a less frequent operation and there can be a backend service to go and update these indices less often. For read, we have to look into the first is getting a value from the index, right? Looking up the index, what's the latency for looking up the index? And let's say indexes are all in memory and we can get it with few nanoseconds. And because the database is huge, few 100,000 records, we assume it is partitioned. So in each partition, the things will happen in parallel where look up a record and get all the records for that index. That's an order of one. Okay, here. Okay, in each record, how much data we have will constitute the order of operation, right? Looking up based on one if there is a single key value pair, there is only one value for each key, then it's an order of one operation in every partition. But here we would have a list of things. So we wanted to match this list or traversing the list to the overall high level read latency we are targeting. We wanted a very low latency. We wanted to have this list as small as possible in each partition. So maybe
okay, there you go.
Yeah.
So like a smaller list in each partition. Okay.
Yeah.
So that kind of is helpful because like if you start with 100 million, it's going to take a long time to search.
Long time. Yeah.
But if you
just have 100 elements in. Yeah, I'm making up the number. Yeah.
Okay. So I was like, in my mind, I was kind of thinking like when I was talking to the person on the phone that, you know, like if you start with a letter like R, right? And, you know, this is just like one part of the interview. So if you start with R, right, you know that your phone records, right? If this stuff is out of order, it's going to take a lot longer to go and find this, you know, this person, right? So because like data is largely unsorted, right? So it may make sense to sort the data first. And, like have data available in a sorted manner. So that way, if I want to sort, if I want to look for R, then I know, okay, I can eliminate, just like in the phone book, right? Like all the other values that are less than R and greater than R. And so instead of returning back 100,000 records, I might return back 100,000 records. Right, that should be part of the search. And then again, if I type A, then this should cut down again, and then cut down again. Just making these up here, 1,000 records. So R, A, then M.
How does this work? Like, is that, are you, so the sorting and all will work if you are doing it in memory, right? This thing is persisted in the disk, right? How does sort matter?
Well, that's the thing. We're designing the system, so we haven't made anything yet. Just like saying that.
So is the no, like even for designing, right? Like you would want everything stored in memory, like in some data structure that it kind of, exactly where to go.
Because memory is the fastest. If it's in memory, then, and it's sorted, then that's going to be the fastest experience for the user. If you have to make database calls, it's going to take longer.
Yeah, with that you have the scalability problem, right?
And it's more expensive too.
Yeah. So yeah, if your phone book is only for one city, then it might work. But if you are trying to do it for like the larger, like the entire population or something like that, then like it's not feasible to have everything in memory, keep it sorted. It's you see what I'm saying? Yeah, anyway, so sort, yeah, I don't know, like if it's a great idea to sort the data yourself.
Can I say something here? One data structure that I'm reminded of here is trie data structure.
Thank you.
Is
good.
TRIE. It's greatly used for this purpose, as far as I remember. And this will solve the problem of sorting and everything as well.
Yeah, sometimes these are called prefix trees. Took me some time to remember this, but like, yeah, this will probably be kind of like the best approach for doing this. Like if you're keeping track, but then you would just need to like format the data and, in like the database or the SQL thing that you want to use, or have some way to like back the data. So this is the thing you need to figure out how to model, and then like how to like bring in on the front end and, make it so that it's easy to find the person you're looking for. So you're going through a tree, and you're kind of like saying, okay, give me back everything with G, give me back everything with GE, then give me everything back with GER or K. And then the results get smaller and smaller each time, and it's easier to return back the relevant data that the person might be looking for in the phone book if you're kind of using some kind of drop down. So I don't know, like that's what the interviewer told me. Like, I guess like when I was talking to them, like I was just kind of like going with this kind of basic idea here, like a binary search, along with, using NoSQL. And he was like saying,
at that point, so that's the goal, right? If he's trying to answer a data structure and algo question, then
it wasn't just that though. It was a system design. Like it was.
That's not. You would do this, right? For a system design question, this is the answer. For the data structures question, that's the answer.
Yeah.
So yeah. So it depends upon the context. So yeah. But interestingly, how do you bring them together, right?
Exactly.
Yeah. So Okay, so for string matching and all, tries is a optimum data structure. But like you don't have that kind of control if you are kind of working with external DBs and all, right?
Right. This is why it's interesting. We're all like, some of us are back-end engineers, so like I'm just curious, like how would you actually implement this, right? Like, because this is the theory.
Mm-hmm. Yeah,
So,
maybe there are databases that are optimized for this kind of that's what is Elasticsearch, right? So
mhm.
it is optimized for string lookups. So for a system design question, I would just say, go use Elasticsearch. Now, if the question is how do you design Elasticsearch, then you would want to go to the level of tries and how to optimize, how to minimize the latency for each lookup. Yeah.
Mhm. Yeah, but I think we did a really good job. I mean, like we talked a lot about everything. Like we picked, I think like if anything, like more than anything, like we went and used what we learned in the chapter, which was like the NoSQL, and we compared it to SQL. So that was really good. I remembered stuff like ACID and base, RDMS for like read efficiency, NoSQL for write efficiency.
But there is that open question as to what does consistency really mean, right? I was under the impression that distributed concept is applied for high availability, latency kind of qualities that we desire from a database. So anytime there is a distributed concept, there you are bound to sacrifice. That's the CAP theorem, right? So if you have availability, you can't have consistency. So I was under the impression. So let me go to confirm that. I thought it's nothing about distributed or RDBMS. It's just the way databases are. If you want availability, you can't have consistency. So yeah, that's a follow-up question, I guess.
Well, you can have consistency and availability, but you can't have partial tolerance then, right? That's the CAP theorem. Like you can have out of 3, you can just have 2.
So
only 2 properties you can have it of the 3. Yeah.
So yeah, actually when I was reading this, I had the same question. So what do you mean by how can you achieve? Let's just for the, he almost says in that partition is if you guys understood, like how can you achieve consistency and availability at the same time?
I'm just writing this out here. Feel free to.
So a single node MongoDB instance is a CP system of sorts, right?
Mm-hmm.
In real world, nobody would do it, but technically that's a CP system, right? If it goes down, there is no availability on it, right? Always. So more it relies on the consistency and that particular partition tolerance. So generally,
maybe that the problem here is that the definitions are unclear. So partition tolerance is, it says the system continues to operate despite an arbitrary number of messages being dropped by the network between nodes. If the messages are dropped, then
so messages are like, let's say a backend API is trying to do something to database for whatever reason, just didn't even make it to the right log, right? And then it's lost. The transaction is basically completely lost. That's what really is referred here. See, Cassandra, MongoDB, let's just say most likely you won't talk about a CP system, but this is the reason why CAP theorem is not just applicable for a database. CAP theorem is applicable for any distributed system, right? Like even a messaging system, like Kafka and stuff, where there are multiple nodes and stuff like that. So CAP theorem is applicable across. But in the database world, mostly it's either a CP system or AP system. Generally, you always choose that, most likely the properties, right? even to run a basic development environment, right, where multiple people are doing so.
So basically what you're saying is theoretically it is possible to have consistent and available systems, but there is no guarantee that the data is right. It is consistent,
Exactly.
but it's not right.
Exactly. It's theoretically, it's all possible, right? You can spin up a small thing but in the real world, nobody would do a CP system. Mostly it's CA kind of a system, right? Where
okay. So that is so basically now you're saying your data is not accurate. You're compromising the accuracy.
Exactly, right? See, one of the properties you will always compromise. That's the whole point of CAP theorem. In a distributed world, truly in a distributed world.
Yeah, so data is going to be off, like sort of, if you follow the CAP theorem. Is this because like some people might be using things like Cassandra or something like that, where data may not be updated on time? Is that kind of like the case? There's like a wait period.
I think Cassandra is more of an AP system, if I'm not wrong. For some reason, MongoDB is more of a CP system. Although that is also eventual consistency, but like, they've implemented some kind of a different protocol where consistency is preferred over complete availability. And again, all these things, search query, MongoDB is an anomaly. You can search by whatever we spoke about before, by filter, like how you can do it in RDBMS. You can do aggregates there. So both SQL and NoSQLs are catching up with each other's complementary features as they evolve. So sometimes it's tough to say which one to choose over the other. Like I said, RDBMS now supports JSON structure. A lot of JSON functions, both in MySQL, Postgres, and Oracle SQL Server, everybody support now. So sometimes it's difficult just purely by just the data model, right? It's the use case and the data model has to be combined together to arrive at a solution, which may or may not be always perfect, right? Like I like to think that architecture is any new architecture that you put in place is constantly evolving, iterative, and everything changes every 9 months. It has to, right? Because if the business and everything is constantly changing, the challenges are different. You will iterate some point, like something.
Got it. Okay, just to be consistent with our time, it is 8:38. So what did you all think? Did you like this today? Was this a good change up from what we usually do?
Yeah, I definitely liked it. And I think we should do this instead of just reading through the questions. Yeah, so I think it's the question is kind of I always have this doubt, like, do people expect me to go to the database design, or they just ask me to pick a database and then kind of design the rest of the system, right? Like for example, how do you, the thing that I would add to that discussion, to the phone book discussion, is that if it is a keystroke, right, you have to make sure that you are really high latency low latency application, meaning that you are very sensitive to latency. So let's say I type something and something comes back and the response comes back after 3 keystrokes, right? It's a very annoying experience for the end user. So you want to have a timeout, very low timeout on the client, where it drops the responses that are stale. So I mean, I would focus on that side of things rather than how the database works. So it all depends upon what the interviewer is expecting out of you.
Right. I think what I can do next time is get like a system design like rubric, and we can kind of follow it just to see if we're answering the question to where the way the interviewer might be grading. But yeah, I hear you. I mean, like, I think this time around we took a detour and we decided to just do a problem anyway, just for fun. So this was good. Yeah, just jogs the memory. What I'll do is I'll save this and then I'll share it with you all. And you could put it in the Notion app. Are you still updating that, Amelia?
Yeah, when I stopped reading the book, but yeah, whenever I'm reading, I make notes there. But this is probably I didn't take notes today, but yeah, can you share this in the Discord? So
yes, yeah,
I can kind of put the same thing there and kind of capture the salient points. Yeah.
Okay.
I'll update this with the I'll update the Notion doc.
Okay, sounds good. All right. I'll put this both in WhatsApp. I found the desktop client for this, and I'll put it in the Discord. All right. Then that's basically it for today. I guess we'll see you all on Friday. Thanks for coming, everyone.
Thank you. Bye.
Later, guys. Bye.
Bye.